Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss preparation of aldehydes and ketones. Last class I have discussed nomenclature of aldehyde and ketones. Now I am going to discuss preparation of aldehyde and ketones. Previous classes already I have discussed preparation of aldehyde and ketones. Some common preparation I have discussed, as for example, by oxidation of alcohol. Aldehyde and ketone are generally prepared by oxidation of primary and secondary alcohol. That already I have discussed. Aldehyde and ketones are generally prepared by oxidation of primary and secondary alcohol. And second, also I have discussed second method by dehydrogenation of alcohols. This method is suitable for volatile alcohols and is of industrial application. In this method, alcohol vapors are passed over heavy metal catalyst, as for example, silver or copper. Primary and secondary alcohols give aldehyde and ketones respectively. All these reactions I have discussed many times. And one more what I have discussed, that is from hydrocarbons. In that, by ozonolysis of alkene. In the when I was teaching alkene, that time also I have discussed. Alkene means double bond. Then by ozonolysis of alkene. We know ozonolysis of alkenes followed by reaction with zinc dust and water gives aldehyde or ketones, or a mixture of both depending on the substitution pattern of alkene. Means on the ozonolysis of alkene you will get aldehyde and ketones. Sometimes you will get a mixture of both depending on the substitution pattern of the alkene. And only in this also I have discussed by hydration of alkynes. This was from alkene, ozonolysis of alkene, but from alkyne also it is possible, triple bond, by hydration of alkynes. Addition of water to ethine means triple bond in the presence of H2SO4 and HgSO4 gives acetaldehyde. Okay. All reaction already I have discussed many times. Now I am going to discuss that type of reaction which is new for you. As for example, preparation of aldehyde from acyl chloride. Acyl chloride is also called acid chloride. Then how will you get that? I am going to tell you. From acyl chloride. Acyl chloride, also known as acid chloride, is hydrogenated over catalyst. Which catalyst? Palladium on barium sulfate. This reaction is called Rosenmund reduction. It is very, very important. This reaction is called Rosenmund reduction. Then here you can say acyl chloride. From acyl chloride you will get aldehyde from acyl chloride, also known as acid chloride. How? Then by hydrogenation. By hydrogenation. Acyl chloride is hydrogenated over catalyst. Which catalyst? That is important. Palladium on barium sulfate. This is very, very important. Then here acyl chloride means acid chloride. Then you take example benzoyl chloride. RCOCl, you know, this is the alkyl, this is the chloride actually, acid chloride, acyl chloride. But here in the place of R you can take aromatic ring also, aryl, AR. Means with benzene COCl group is attached. That is called benzoyl chloride. See, chlorobenzene is different. That is only directly chlorine is attached to the benzene ring. But benzoyl chloride is different. It is a COCl. Acyl group is attached to the benzene ring. Acyl, COCl is attached to the benzene ring. Then it is called benzoyl chloride when COCl is attached to benzene ring. Then this will give hydrogenation you are doing, means this benzoyl chloride is reacting with H2 in the presence of palladium on barium sulfate. Then what will happen? Now it is very clear that H2 is there. Then this one H will make HCl with in benzoyl chloride one Cl is there, that will react with H and it will go as HCl, and in its place H will come. In the place of Cl another H will come, H2, 2H was there. Then you know if it will break, then one H will be as H plus, other will be as H minus. Then H plus will go to the Cl minus, it will form HCl. When Cl gone from the COCl, then that carbon was positive. Then now H negative will join there. Then it will form CHO. In CHO, carbon and oxygen is double bond. What was in benzoyl chloride? That way, same way. Only in the place of Cl, H came. Cl minus went and H minus joined there. Very simple way. Then now you got benzaldehyde. Now second method, new method I am telling you, from nitrile esters. From nitrile esters. Nitriles are reduced. Here also reduction is going on. Just what I discussed, there also reduction was going on. Here also reduction will go. But that time, this in presence of palladium barium sulfate, it was called reduction was called Rosenmund reduction. Very, very important reaction. Rosenmund reduction. Question is asked. Now I am telling from nitrile and esters. From nitriles and ester. Nitriles are reduced to corresponding imine. Imine, I-M-I-N-E, imine, with stannous chloride in the presence of hydrochloric acid, means SnCl2 and HCl. You remember, this is again very, very important reaction for reduction. For the reduction, SnCl2 and HCl is used. Then nitriles are reduced to corresponding imine. First things, okay, and this imine which on hydrolysis give corresponding aldehyde. First step it will give imine, and imine on hydrolysis it gives aldehyde. Reaction I am telling you, nitrile RCN, alkyl nitrile, RCN, CNN triple bond is there, CNN triple bond, okay. Then RCN plus SN2, SnCl2 plus HCl. Actually this reaction is called Stephen reaction. This is also important. All name reactions are very, very important. Always remember, all name reactions are very, very important. Then RCN plus SnCl2 plus HCl. What will happen? Now I told you RCN, C and N has triple bond. Then one bond will break. Then now only two bond will remain. And when one bond will break, then what will happen? N is electronegative. Hence electron will be taken by N and it will become negative. And carbon will become positive. Then now hydrogen, one hydrogen, two hydrogen will join, one with N and other with H. One with H, other, actually two nitrogen will join, one with N and other hydrogen with C. Then this is called imine. Now we got RCHNH, CHNH double bond, triple bond became double bond. And now hydrolysis of this imine means RCH double bond NH. This is called imine. Imine on hydrolysis in presence of acid, it will convert imine into aldehyde. Aldehyde, okay, means RCHO. RCHO you will get, okay. Then now here what happened to the NH? RCHO you got, double bond there, double bond was there, that O came, that is equivalent to double bond, okay. Then RCHO you got, RCH means aldehyde you got. What happened to the NH? Then now this NH, if two hydrogen will come to this, it will form ammonia gas, NH3, okay. Actually this reaction, imine hydrolysis takes place as a H3O plus, hydronium ion, H3O plus. Then you got a RCHO, and this NH gone as NH3, correct? NH3, two hydrogen joined with, because nitrogen when bond break and double bond, then it was having ability to join two hydrogen because it was negatively charged. Then two hydrogen positive H plus can join. Then it will form NH3, ammonia gas, correct? And this another part was important product, that is the O has joined. O has joined. Then it became, because when it went, carbon was having two positive, then oxygen went there, correct? Oxygen joined there. And this RCH double bond was there, nitrogen and taken, that time nitrogen has taken electron, hence carbon was having two positive, that's why oxygen went there. And now nitrogen has two negative, hence it can join two positive charge, means two hydrogen. That's why it went as NH3. And an alternative method I am telling you for nitrile. Nitriles are selectively reduced by diisobutyl aluminum hydride. Now you can see this is very important reaction. That is, nitriles are reduced by, it is called selective reduction. Means nitriles are selectively reduced by diisobutyl aluminum hydride. In shortcut you can tell DIBAL-H. D means di, I means isobutyl, IB means isobutyl, aluminum, A means aluminum, Al means aluminum, and hydride, H is there in the end, H means hydride, DIBAL, remember, DIBAL, diisobutyl aluminum hydride. D means di, and IB means isobutyl, and Al means aluminum, and H means hydride. Then this nitriles will convert to imines, followed by hydrolysis it will give aldehyde. Same way, RCN in presence of aluminum, in presence of DIBAL-H, means diisobutyl aluminum hydride, it will convert to RCHO. You can also write in a formula form diisobutyl aluminum hydride. You can write like this also, ALH, and in bracket you can write IBU whole 2. ALH in bracket IBU whole 2. Okay, and in presence of water directly you will get aldehyde. Okay, now same way, on the same basis you can make you can say this reducing agent DIABAL-H can also used for long carbon chain which has double bond, which has carbon-carbon double bond. As for example, CH3, CH, double bond CH, after that CH2, and the end CN. Correct? In the end CN is there. Total number of carbon 1, 2, 3, 4, 5. 5 carbons are there. Then first carbon is CH3, second is CH, and third is also CH. CH is double bond. 3 carbon is over. After that CH2, 5 carbon. And then CN is there. Then if you count this C, then it will be 6. Okay. Then same reducing agent, diisobutyl aluminum hydride. It will give you same way, nothing will happen, only in the end CN will convert to CHO. That is important. CN converts to CHO. This you remember. Nitriles convert to aldehyde. Only this you remember. Okay. Similarly, now ester. Come to the ester. Esters are also reduced to aldehydes with same reducing agent DIBAL-H. DIBAL-H. Okay, means diisobutyl aluminum hydride. Then RCOOR. This is the general formula of ester. RCOOR. Correct? Then here you know that RC double OR, double O, means R and C and O, first oxygen has double bond, and second oxygen is joined with carbon by single bond, and that oxygen only is joined by R, another R, with single bond. This formula is useful. This way you remember. Already I discussed many times. Ester you can remember as a COOR group. Then R, COOR. Then one oxygen is double bond, CO. Other oxygen is single bond. And that from that oxygen another R is attached. This way you remember. Then here what will happen, that R may be any alkyl group, may be CH3, CH2, whole 9, very long chain also may be there, short chain also may be there. CH2 whole 9 means you can understand. We are talking about 9, CH2 whole 9, 9 times CH2, 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 you have to write. CH3 in the beginning, CH2 whole 9, means 9 times you have to write in the place of R. In the place of R in the beginning. After that, C is attached to the oxygen with double bond, and another oxygen is attached with O, and that O is now here attached with ethyl group. Ethyl group. Then you have to not do anything with a long chain. It will be as it is. Now here what will happen, that this is the reduction process. Reduction. Then here OC2H5. OC2H5. It will go as ethyl alcohol. C2H5OH. Correct? Then here 2H will be used. 1H will go with, because this bond will break. OR bond, O and R single bond, that will break. Means O and carbon bond, OC2H5, you can tell, O bond between carbon and OC2H5, that bond will break. Then oxygen will take the electron, it will be negative. It will be negative, carbon will be a positive. Then here what will happen, one H will join with carbon and other H will go to oxygen. Then it will form C2H5OH. And one H joined with carbon. Then now ester group now converted to CHO group or COH group, aldehyde group. Correct? The OC2H5, it went as a C2H5OH, ethyl alcohol. Because two hydrogen only used a pair. One hydrogen came joined with carbon and one other hydrogen joined with O. Okay. Then you can also understand this reaction, that because hydrolysis first reaction will take place in presence of reducing agent DIBAL-H, and after that hydrolysis, then process will follow same way what I have discussed earlier, same way, but in a simple way you can understand that because H2O will be there, H and OH will be there. Correct? Then this H and OH, that way also you can understand. Okay, what I discussed earlier method, same way, but very easy way you can understand that one H will go to carbon, other H will go to OC2H5. Then OC2H5 will make ethyl alcohol and one H will join with carbon. Means this ester group now converted to aldehyde group. CO is common, C double bond O, that has not disturbed, only another bond broken. That's simple way. Now next you can say preparation I am telling you from hydrocarbons. Aromatic aldehyde means benzaldehyde and its derivative are prepared from aromatic hydrocarbons. Means benzene ring you will use here. Then aromatic aldehyde are prepared from aromatic hydrocarbons. Then how? Then I am telling you, by oxidation of methylbenzene. By oxidation of methylbenzene means when methyl group is attached, that is also called toluene. Then from that way also you can make means oxidation of methylbenzene. But here which oxidizing agent you will use? Then a strong oxidizing agents oxidize toluene and its derivative to benzoic acids. However, it is possible to stop the oxidation at the aldehyde stage with suitable reagents that convert methyl group to an intermediate that is difficult to oxidize further. Then now example I am telling you that here oxidizing agent we will use CrO2Cl2 which is called chromyl chloride. Use of chromyl chloride, by use of chromyl chloride you can get benzaldehyde. Okay. Chromyl chloride oxidizes methyl group to chromium complex. First chromyl chloride will oxidize methyl group to chromium complex, which on hydrolysis gives corresponding benzaldehyde. Reaction is Iitjee, means CH3 toluene is there, then that 2H2 CH3 3 hydrogen is there, then out of 3 hydrogen 2 hydrogen will go from here and in its place oxygen will join. CrO2Cl2 is there, then that CrO2, that one oxygen will join with, in the place of 2 hydrogen that is equivalent to 1 oxygen. 2 hydrogen is equivalent to 1 oxygen. It can, when it will substitute, it will remove 2 hydrogen, then oxygen can join. Then CH3, now it will come CH and 1 oxygen joined with carbon. Then you will get, what you will get? Only 1 hydrogen is remaining, CH, and now we will get remaining CrO2Cl2, 1 oxygen joined, correct? Then after that what is remaining, that will be attached with that oxygen. Oxygen is joining with remaining CrOCl2, you can tell. It has not means free. Oxygen is joined with chromium also and oxygen joined with carbon also, correct? Hence you will get actually COCrOHCl2 whole 2. Okay. Here you have to understand that 2 hydrogen actually it is involved only here in this complex. Then here actually 2 hydrogen gone. Then here actually that 2 hydrogen, now OCRH, Cl2 is as it is. 2 oxygen is also there, not a problem. But 2 molecules, if you will take 2 molecules of CrO2Cl2, if you take 2 molecules of CrO2Cl2, then what will happen? Then 2 hydrogen what is gone from the CH3. Now each hydrogen is joined with O of CrO2Cl2. Both each H has joined with CrOCl2, correct? Then actually these 2 H has come with this CrO2Cl2. It became OCrOH. One H came here. OH. Cl2 as it is. Like that way, when other hydrogen moved, then again same things happened. Again you can say OCr, OHCl2 has come, because that hydrogen now came with oxygen. Two oxygen was there with chromium chloride. Then this chromyl chloride, two oxygen was there. Then these two hydrogen which gone from the methyl group, methyl CH3, that one went with one molecule of chromyl chloride, and other went with other you can say with other chromyl it went. Hence you will get whole 2 CHOCrOH. OH in chromyl chloride became OH, correct? OH, because when oxygen bond broken, because it has joined with carbon, then that time oxygen became negative charge. That's why hydrogen went to there. Okay, then you will get actually complex, you will get intermediate, that is called chromium complex. Means now you will get benzene ring. With benzene ring CH3 was there, CH3, then from 2 hydrogen replaced with 2 chromyl chloride molecule, then it formed OCrOH. O became OH, Cl2 as it is, whole 2. And in the second step, on hydrolysis, what will happen? Hydrolysis, that oxygen will come to the CH. Oxygen will come to the CH and it will form CHO. Then two bond broken, and then on that place oxygen joined. Okay, when bond will with CH, 2 bond was there, OCr OHCl2, again OCr OHCl2, these 2 bond broken. Then O from H2O came here, and now it formed CHO, aldehyde group came. CH was already there, only oxygen came when bond broken. Okay, 2 bond broken, then 2 electron was available with you can say carbon. Then that is there actually oxygen joined. Okay, but here you should understand, because carbon and oxygen bond will break, then oxygen will be negative. Both oxygen will be negative and carbon will be positive, correct? Then here oxygen that H2O, that situation will be different. Oxygen will go there. H2O, H plus 2H, H2O will break. Then oxygen will be negative charge. Hydrogen will be positive. Then 2 hydrogen will go to this oxygen which was negative. 2H will go there, and O will come to the carbon with electron, and it will give to the carbon. Okay, then now this group, now you got CHO group which is attached to benzaldehyde. This reaction is also very important reaction. It is called Iitjee reaction. Always in examination this question is asked. Okay, Iitjee, Iitjee reaction. Whenever I can say any reaction is complicated, any reaction which is complicated, generally that is called by a name reaction. Here it is a complex form, is little, not too much, little complicated. Okay, because they form complex with chromyl chloride, correct? Then this reaction got special attention. Then this reaction is called Iitjee reaction. Okay. Then here you can say how you are getting, you can say from hydrocarbon. From hydrocarbon, that by oxidation. By oxidation. Chromyl chloride. Here oxidizing agent, here you have used, that is chromyl chloride. Okay, chromyl chloride oxidizes methyl group to chromium complex. This reaction you remember. Now another reaction I am telling you, means from hydrocarbon, another method I am telling you, use of chromium oxide. This time you will use only chromium oxide, CrO3. CrO3. Toluene or substituted toluene is converted to benzylidene. Here you see, not getting benzaldehyde, benzylidene diacetate. Benzylidene diacetate, treating with chromic oxide in acetic anhydride. The benzylidene diacetate can be hydrolyzed to corresponding benzaldehyde with aqueous acid. Here this is not a reaction, looks like complicated, but it is not very complicated. Here you will use oxidizing agent CrO3. Then oxidizing agent role is that it will supply oxygen. Very simple way. Then now suppose same thing toluene you are using. You can use, you can say substituted toluene also. Means other group also may be attached. But here you take example of toluene only. Toluene plus CrO3 plus acetic anhydride. Then acetic anhydride formula you know very easily. O you write in the middle and both side CH3CO. Oxygen has two valency, then with one valency CH3CO, other also CH3CO. Means oxygen is attached to the carbon, CH3CO. Then that carbon, again right side also same way. Oxygen is joined with carbon. Okay. Then CH3CO and that carbon joined with oxygen. Then both sides CH3CO, oxygen is bonded with both. This is the acetic anhydride. Here you will maintain the temperature around 283 Kelvin. 283 Kelvin, not more. 10 degrees centigrade. You are talking in Kelvin. 283. Then here what will happen actually, you know that CH3 is there. CH3 is there. Then 2 hydrogen from the methyl, it will go, and in its place oxygen will come. Very simple way. CH3, one H will remain only here with carbon, 2 hydrogen will go, and in its place 1 oxygen will come. Then now you got directly you got the product. But here via media is there. You will not get direct. You will get one intermediate. Like what I have discussed. Earlier this reaction. Same way, one intermediate you will get, and after hydrolysis you will get aldehyde. But simple way I told you that CH3 is there and oxidizing agent is there. Then 2 hydrogen will go from the C, and in its place 1 oxygen will join. Okay, you got the CHO. But correct method I am telling you, means exact intermediate you will get. What is the name of intermediate? Then that intermediate name is benzylidene diacetate. Benzylidene diacetate. Then how will you get this benzylidene diacetate? Then now we are understanding. This is due to this thing's anhydride, acetic anhydride. You have used acetic anhydride, then there is a scope of CH3CO, CH3CO, 2 times is there, and in the middle oxygen is there. Then you know, whenever it will break, any one side C and O bond will break. Then 2 oxygen will come close. Always you remember, 2 oxygen it will be 2 part. One part will be CH3CO and remaining part will be CH3COO. That O will be negative. But in CH3CO, that C will be positive. You remember. Now here same way you will get when with each hydrogen when it will break CH3, when 2 H will go, then 1 by 1 it will go, 1 H will go, then one bond will form. That is the OCO-CH3. OCO-CH3. Okay, means CH3CO one part don't consider, leave it. CH3COO minus, that part joined, because H gone as H plus from the CH3. Then here you can say 1 H gone as simply consider for H gone. Then there it will join CH3 COO, CH3CO, this thing CH3COO, that part will join. CH3COO. Here CH3COO means one bond, carbon oxygen is double bond, other is a single bond, but this oxygen is negative charge because bond is broken and electron is taken by oxygen. Then this O negative has joined with carbon. Same way other hydrogen now gone. Then again another CH3CO joined. Then 2 hydrogen gone and 2 CH3CO joined. That is the whole 2. That's why it is called benzylidene. Benzylidene. Then now we got intermediate product CHCO, CH3, whole 2. H is outside, in bracket OCO, CH3, whole 2. Second part of acetic anhydride. Then first part is CH3CO. What will happen to that CH3CO? Then now here this CH3CO, that is a positive charge. Carbon is positive charge. CH3CO, that because bond broken, then electron is taken by oxygen. Then another part got positive. Then here actually what happened, that hydrogen will now come here and it will join here. Okay, then you will get CH3OH, CH3 C double bond, and H will join there. H will join with that CH3CO. Okay. Also you can understand that it will be actually because that carbon is positive charge, then negative part should come. It will actually alcohol, it will form alcohol, because methyl alcohol, this ethyl alcohol it will form. CH3 is there. Then now that this C double bond O, CH3CO, that is the first part of the anhydride, correct? That carbon is positively charged. Then here what will happen? that now this time C and O double bond will break and it will give electron to the carbon, correct, and oxygen will negative, oxygen will become negative, okay, and there H plus will come, H plus will come, okay, then it will form CH3. This thing, not only one will hydrogen will come, because CH3, C double O is there, CH3, then it will form actually this thing, CH3 CHO, aldehyde group it will form. It will form aldehyde group. One H if you will get, then it will form CH3 CHO, CH3 CHO aldehyde group it will form. Then now here you have seen that chromium oxide that converted to this toluene converted to benzalidene diacetate, okay. Then this diacetate now on hydrolysis that given benzaldehyde on hydrolysis. Then second part CH3CO, that is the, you can say these things I told you that CH3 C double bond carbon was there, that was positive charge. Then actually that on hydrolysis that time actually one more possibility is there, that H plus OH, and that carbon was positive, then OH may join there, okay, then you will get acid CH3 C double OH, this is the more stable, okay. Then like that way 2 molecules of acetic acid you will get, acetic acid CH3 C double O OH, correct, and hydrogen you can say already that because oxidation you have done, 2 hydrogen came out, then it is oxidizing agent that may convert to water H2O, okay. Then I told you that toluene will convert to an oxidation with chromium oxide in presence of acetic anhydride. When you are maintaining temperature at 283 Kelvin, it will convert to first benzalidene diacetate, and that will convert to the aldehyde when it will be hydrolyzed, okay. Now one more I am telling you these things, same toluene by chain chlorination. Third method you can tell by side chain chlorination followed by hydrolysis. Then here see again you are taking same example toluene. Then toluene is reacting with chlorine in presence of UV light. Then what will happen? 1 by 1, actually CH3 is there, 1 H will go and it will react with Cl. Cl2 is there, then Cl will break into Cl plus, but here UV light is there, means radical reaction will take place by radical mechanism. Cl2, each Cl will get one electron, and that toluene, that H bond will also break in a radical form. Then 1 H and 1 Cl, both will form a Cl. Then 1 electron is with carbon of CH3, that carbon. Then and again after that 1 chlorine is with, you can say 1 electron is with the chlorine, second chlorine. Then that will attach there. Okay, then it will form CHCl2, means 2 hydrogen gone, 2 Cl joined, 2H gone and 2 Cl joined by radical mechanism. Correct? Very simple way. This is called benzyl chloride. benzyl, B-E-N-Z-A-L, benzyl chloride, CHCl2. You don't forget, if CHCl2 is joined with benzene, it is called benzyl chloride. Only if one Cl is joined, then it is chlorobenzene. But if CHCl2 is joined, CH, one carbon is joining CHCl2, then it is called benzyl chloride. And this benzyl chloride on hydrolysis, what it will give? 2Cl, one oxygen will go and 2Cl will join. Both are electronegative. Both Cl will go, both are negative, will go with electron, and oxygen can join very easily there. Substitution, but both are electronegative. Then now CH was already there, one oxygen came, hence it will form benzyl dehyde. Okay, this is very, very important reaction. One more reaction I am telling you. Okay, by Gattermann-Koch reaction, very, very important reaction. Already I told you, all name reactions are very, very important. Then by Gattermann-Koch reaction. What is this reaction? Then I am telling you, when benzene or its derivative is treated with carbon monoxide and hydrogen chloride, HCl, in the presence of anhydrous aluminum chloride, means AlCl3, or cuprous chloride, CuCl, then directly it will convert to benzyl dehyde. Means benzene is reacting with carbon monoxide and HCl. When benzene or its derivative is treated with carbon monoxide and HCl in the presence of anhydrous aluminum chloride or cuprous chloride, it gives benzyl dehyde or substituted benzyl dehyde. Then now here carbon monoxide is there and HCl is there. Then directly, actually, when CO will join, then that CO carbon monoxide, correct? That is actually multiple bond. You can tell multiple bond is there. Okay. Then that carbon H will go there. Obviously H has to go from the benzene, correct? Then generally it will go as H plus, correct? Then that in CO oxygen is electronegative. Then O will take electron. Oxygen is electron negative atom, hence it will be negative, and carbon will be positive. Hence this carbon will join with benzene ring. Okay. And actually it is HCl is also there. So much you can say conditions are there. HCl is there, AlCl3 is there. Then here actually H will not go as a H plus. It will not go as a H plus because carbon is positively charged, hence it will go to that carbon which is negatively. Then if H will go as a H plus, only then carbon will have negative charge. Here H will go, bond will break. To break the bond, these so much conditions are required. Then here H is going as H plus, then carbon of the benzene ring, that will negative, and CO which is positively charged, CO in that C is positively charged because oxygen is electronegative, that will join with this carbon. Then now connection took place. Now CO has carbon monoxide has joined with benzene. That happened, main work has happened. And after that you can say these things, H you have to introduce. CO is there, H you have to introduce. Then what will happen? Then this double bond, because this carbon is electronegative, then there that will be oxygen always will be negative only. Hence here what will happen, CO is there, then there H will join. HCl is there, that H will join there. Correct? Carbon CO, oxygen is negative, and it will, one bond will break, and then CO will be negative, carbon will be positive. Then here what will happen, H will join with O. H will join with, but no, not with O. Actually here, because in CHO, C and O is a double bond. Hence that bond will not break, sure. Then how it will join? Then H has to join with direct with the carbon of CO. Then here, from the benzene, H has gone as H plus. Then that H plus actually it will join with carbon, directly with carbon. And how it will, directly it will not join, directly it will not go and it will join. Here AlCl3 is there, CuCl is there, anhydrous aluminum chloride, and CuCl is there. Then actually this will help, aluminum chloride and CuCl will help. It will create, you can say, on carbon negative charge. These will create AlCl3 and CuCl. This will create negative charge on carbon, and then H will join there. Then you will get CHO. In that C will be double bond, H will be H and carbon single bond. Okay, temporarily this AlCl3 will make a complex, and after establishing H, it will leave there. Okay, electron actually will be taken by that, it will create carbon will get negative charge due to AlCl3. Okay, and also you can understand in Iitjee way, because oxygen always has a lone pair of electron. Correct? Hence this carbon, their arrangement will be like that carbon will be negative. With help of AlCl3 or CuCl, carbon will get negative, and then hydrogen will, H plus will join there. That's like this way you will get CHO, that is called benzaldehyde. Okay. Now actually this reaction is called actually Gattermann-Koch reaction. Gatter, G-A-T-T-E-R-M-A-N, Gattermann-Koch, Koch reaction. This reaction is very, very important. Asked in examination, their its mechanism is little difficult. Okay, because it has to create carbocation, it has to, an anion, carboanion it has to create. Okay, then it will take 1-2 step, only then here negative charge will be created. Okay, thank you.